You're welcome to another video. So today you want to look at how to find the shaded area in a region bounded by two curves, y is equals to 2x squared and y is equals to 27 minus x squared. So we're going to take you through step by step, and this area can simply be calculated by integration method, trapezoidal rule, and the mid-ordinate rule. So I'm going to take you through step by step up to the final solution, and right away let's dive into the solution. So remember to subscribe, like, share, leave a comment if you're watching us for the first time. So on the solution part, you realize the area that we're going to find its area is here, the shaded one. It's being bounded by that curve y is equals to 2x squared and another curve y is equals to 27 minus x squared. So right away, for me to find the area, I need to find the limits, meaning the endpoints where the two lines intersect. So that will give me the boundaries. So for me to do it, I'm going to equate the two curves. So it was 2x squared. I'm going to equate to the other one, 27 minus x squared. So collecting like terms, I'm going to get 3x squared is equals to 27, of which I can take 27 on the other side. I'll get 3x squared minus 27 is equals to 0. Then I can decide to divide all through by 3 by 3 by 3, so that I get x squared minus 9 is equals to 0. Of course, that is a quadratic equation. I expect two solutions, and recall that this is in the form of a squared minus b squared, meaning I'm going to get my answer in form of a minus b, a plus b. So applying this rule here, then it goes without saying that the value of x is going to be x minus 3, x plus 3 is equals to 0, which of course gives me x is equals to positive 3 and x is equals to negative 3, meaning at this particular point where the curves are intersecting, it's gonna be 3, and negative 3, it may be on the other side if we try extrapolating our two curves. So this side gonna be negative 3, like that. So I'm gonna start with the first approach. The first method of finding our shaded area gonna be the integration method. The integration method. And since I know the limits, I'm going to integrate this particular point P, that curve going like that, from 0 to 3 of the curve is 27 minus x squared with respect to x. Then I'm going to subtract this curve 0 to 3 of x squared with respect to x. It was 2x squared, like that. So by doing this method, the integration method, then of course I'm gonna get the actual area that is shaded. So let's continue. If I integrate 27 minus x squared, of course I'm gonna get 27x minus x cubic over 3. Then I'm going to subtract on the other side. If you integrate 2x squared, you're going to get 2x cubic over 3. and then the limit is 3 to 0, like that. So the first, when you substitute 3 at this particular point, you're gonna get 81 minus, if you substitute 3, you're gonna get 27 over 3, then minus, of course, when you substitute 0, you're gonna get 0. On the other side, I'm gonna get 2 multiplied by 27 over 3. Of course, when I substitute 3. Solving it further, I'm gonna get this side as 81 minus 9. Subtract 18, which of course it's gonna give me 72 minus 18. Of course, the area becomes 54 square units. That is using the integration part. I'm gonna use the second approach called the trapezoidal rule, so that we compare how the area gonna behave. I know that the rule says that for me to find the area, I need to take a half of the h meaning the number of strips, and I've been given the number of strips to use will be 3. The last y minus the first y plus twice the remaining y's, like that. But for me to get h, I'm gonna take the boundary, that is xn minus x naught, divide by the number of strips. Since I have 3 strips there, so that means 3 minus 0, divide by 3. Of course, the value of h goes without saying that it is 1. So applying this rule, then it means I'm gonna create a table for the values of x and y for this first curve, this one. For y is equals to 27 minus x squared, I'm gonna create a table. Of course, that means I'm gonna divide this area into 3 trapeziums, like that. So when I substitute 0 in this equation, the output gonna be, of course, 27. When you substitute 1, gives you 26. When you substitute 2, gives you 23. And when you substitute 3, it's gonna give you 18. So well, since I have the values of y, I'm gonna substitute them in the formula for the trapezoidal rule, so that now I have a half multiplied by h. My h is here. 1 multiplied by the final h, or the final y, which was 18, plus the initial y, multiply, add the remaining, that is 26 plus 23, like that. Computing it further, I'm gonna get 45 plus 98, and then a half outside. Solving this further, I'm gonna get the answer as 71 and a half units, square units, for the area bounded by this curve, like that. So of course, for the second value of this curve, y is equals to 2x squared. When I substitute 0, then the output is 0. When it is 1, the output is 2. And when it is 2, the output is y. And when it is 3, the output is 18. So this is going to give me the area under this other curve. If you look at it keenly, so area under it, this side. Then I'm going to subtract the two answers. I'm going to subtract the upper part, which was 71.5, and what I'm going to get there. So that means I'm going to take 0 plus 18 plus twice the remaining 2 plus 8. Solving that further, I'm going to get a half multiplied by 1, which is that a half. And then that is 18 plus 10. 18 plus 10, which is giving me 38 divided by 2. And of course, it goes without saying that the area bounded by that region, under it, I'm gonna get 19 square units. So guys, take this opportunity to subscribe, like, share, leave a comment, and you turn your notification on. So final area, using the trapezoidal rule, I'm going to take 71.5 minus 19. Then it means that my final answer now becomes 52.5 square units. Of course, if you can compare the answer using the trapezoidal rule is 52.5, and the other one was 54 square units. So guys, you have come to the end of this session. I hope you have enjoyed, you've learned. Kindly remember to subscribe, like, share. So until we meet again in the next video, goodbye for now.